Okay, so in looking at number 9, um, under the stress, we have von Mises, which we talked about, is just where the ultimate maximum would be. And really, that's going to be the answer to this question. That's probably what I should have asked. But the first principle stress, which is under here, is basically helping you understand the maximum tensile stress. But because we don't have any tensile, we're just kind of compressing it. The third principle stress would kind of give us that value. So the third principle stress helps you find the maximum compressive stress. So first principle is for maximum tensile, and then third principle will be maximum compression. And my answer, I have coded the for the von Mises, but the third principle is pretty darn close, so that's what you'd select is the basically the 35.82 for the answer. I believe that's the first answer. Okay, looking at number 16, in this case now we're doing the tensile stress. So on number 16, we want to look at the first principle stress because that tells us the maximum tensile stress because we're in tension, not the third principle stress. So in this case, because we are pulling it kind of all tensile, if we go to the von Mises stress, it's going to be basically the same. But the first principle stress will tell us the maximum. So that would be 180 megapascals, and there should be an answer in there for that. And then the last question that came up, let's see. So the last one is related to number 16. So it's number 17. And I'm just asking for the displacement of one end of the bar. One end of the bar, how much does it displace? So if you go to displacement in total, you get about that 6.6449, and that would be the third answer down. So that would be for displacement. I'm not looking for, displacement, how much does a total elongate multiplied by 2, but I'm just asking for one end. Looks like I got a little typo in the quiz where I said on end. I'll change that to one end. So that hopefully is helpful for 9, 16, and 17. I'll get this posted.